Okay, in this video, we're going to be doing Calc Problem Set 69, the problems, and the playlist are in the description below. Let's do the problems. Number one, given f of x is arctan of 2x, use the tangent line at x equals root 3 over 2 to approximate f of 2. So this is going to be weird because we're going to have things in terms of pi, we're going to have radicals, and then we're going to try to approximate something. We're not really going to know what the approximation is in decimal form, but we'll get the exact approximation and live with it. So we're going to need to know the derivative. The derivative of arctan in general is 1 over 1 plus u squared times the derivative of u. So in this case, we're going to get the derivative of u is 2, so 1 plus the quantity u, 2x, squared, which you can simplify if you want to, but in this case, because of what we're plugging in, it's actually easier not to simplify that, I think. Well, I think. I mean, it doesn't really matter, but I'm going to let x equal root 3 over 2, and then 2 times root 3 over 2 is just root 3. So it is, I think, a little bit easier there. So that's going to be 2 over 1 plus 3, so 2 over 4, which is 1/2. So that's our slope. We also need the value of the function, which in this particular case is maybe harder to find than, I actually think it's harder to find than the derivative because it comes down to do you remember, right? So what's the arctan of root 3? Well, I always think, so what I literally think is that pi over 6 has a nice sine value. It's 1/2. It has an ugly tangent value. It's root 3 over 3. Pi over 3 has the opposite. It has an ugly sine value, but a nicer tan value. So the tan value is root 3, so this is pi over 3. That's how I remember it. I don't know. Choose your method and just go with it. So I'm going to write the tangent line. The tangent line is going to look weird. It's y minus pi over 3 equals 1/2, which was the slope, quantity x minus root 3 over 2. Then we're supposed to approximate f of 2. So we're just going to take 2 and plug it in. We're going to move the pi over 3 to the other side, and we're going to definitely use approximately equal to. So we have f of 2 is approximately equal to the pi over 3, and then plus 1/2 the quantity 2 minus root 3 over 2. Do we know what that value is? Not at all, but it doesn't matter because that's how you approximate things, so that's what we did. And it doesn't, nothing you do is going to make that look better, other than maybe getting a decimal, but then you're less exact. So, I don't know. You gotta decide what you want to do there. I'm leaving it like that because it doesn't say to use a calculator. All right, next up. Use the table of values for f and g at x equals -2 to evaluate h prime of -2 for h of x equals f of x plus 2g of x all over g of x. Okay, so we could dive right in and use the quotient rule on this, but I actually think it's a little bit easier if we separate it because you'll notice you have 2g of x divided by g of x. So I'm going to rewrite this thing as h of x is actually f of x over g of x and then just plus 2. What's nice about that is the derivative of 2 is 0, so that'll be gone. And the derivative of f over g is literally just the quotient rule. So our derivative is going to be bottom, derivative of the top, which is f prime, minus top, which is f, derivative of the bottom, so g prime, all over the bottom squared, so all over g of x quantity squared. All right, so now what we need to do is plug in -2. I'm a big advocate of showing this step. I understand if you don't on this particular problem because there's not a lot going on. Everything is just -2, but it's still useful. Now we got to read off the table. So we need g of -2, which is 2, and we need f prime of -2, which is -2. So it's going to be 2 times -2. And then f of -2 is 3, and g prime of -2 is 4, and then all over 2 squared. So you got to read the table, you got to work that out. This gives you -16 over 4, which is -4, and there you go. All right, let's take a look at one more problem, which is kind of similar. Oh, it's got a little twist, but it's kind of similar. Use the table of values for f and f prime to find k. And if you look in the table, you'll see k. K is f prime of 2. So we want to find k, given that g of x is x squared times f of -x, and we know that g prime of -2 is 3. So let's find g prime. It's a product, so product rule. Just don't forget the chain rule on the derivative of f of -x, so negative f prime of -x, and then f of -x, and then times 2x. All right, so that's normal product rule. Now we got to sub in. So this is where I really advocate showing this step, especially on a problem like this, where you're going to take the opposite of some values because you have negative x's. So we're going to just plug in -2 everywhere we see an x. We get quantity -2 squared, f minus or times negative f prime of +2, plus f of positive 2, and then times 2 times negative 2, so negative 4. All right, we go to the table. F prime of 2 is k. That's the thing we're trying to find. F of 2 is 5. So we're subbing those in and just kind of like mathing this out. So we're going to get 4. We're going to get k. Oh, but it should be negative. So I knew this, so I'm going to screw this up a couple times. I like checked it over and I was like, why is there that negative sign there? There's a negative there because there should be a negative there. All right, and then here we have plus 5 times negative 4. Okay, we're good. Now this will be equal to 3 because we're told that g prime of negative 2 is 3. Okay, so now I'm about to, I think, get this wrong. So negative 4k minus 20 equals 3. Negative 4k equals 23. K is equal to negative 23 over 4. I forgot a negative sign in the answer because I forgot a negative sign when I was doing the work, so let me just put it in. There we go. You know what's weird is I actually checked this one ahead of time, and I was just like, why is there a negative sign there? And I erased it, and I then made it wrong. This is why I don't know. Check your work if you want. I'm not a big fan of checking my work. I'm a big fan of doing the problem and then thinking about whether or not I think the answer is, accurate or reasonable. And if it is, I tend to move on. I tend not to overanalyze it. I overanalyzed this one, and I went from a correct answer to a wrong answer, and then I realized while recording it and fixed it, I think the answer is negative 23 over 4. If you don't think that, I don't know. Let me know in the comments. That's the end of the problem set. I hope this was helpful, and good luck.